Hi guys, today I'm going to talk about how to work with Genome2D in Haxe. So how to compile Genome2D, what do you need to download and how to set it up. It's pretty easy, so let's start. These are my repositories on GitHub. So which you will need is a Genome2D core. You can download it using the zip or just set up GitHub in your UI. I set up my GitHub inside IntelliJ and it works great even with multiple repositories inside a single project. Next one will be context flash or HTML if you want to deploy to HTML5, but we are going to use flash context, and of course you will need a context common, which are common context classes and abstract classes that are the same for both flash and HTML and additional contexts that will follow. And that's pretty much it. We are not going to use the examples. You can download examples later if you want to try them out, and there are in Haxe. You even have the Flash HXML and JS build file as well, and there are assets which are in the root directory because they are common for both AS3 examples and Haxe examples as well. So when you download all these, this is how I set up it in my UI. So what I do is I have a Haxe project, Genome2D, and I have a source file, and then this source file contains multiple repositories, so I have them separately. For example, this core directory contains the Genome2D core repository. This is the actual repository, and there is the source file from the repository. Then there I have context, which doesn't have a direct repository, but there is a common and flash context repository and HTML as well. And then I'm going to ignore the examples, as I said. I'm going to use a custom test just for this showcase. This is just a simple demo I did a few hours back to show a masking rectangle. It doesn't matter, we are just going to show that you can compile Haxe project with Genome2D sources together. So I have my build file for the test. First is the source classes, and I need to mention here that I have a general or a global build file which is called in my UI. This is the actual build file which is always called. So when I change to now, let's say I want to build examples for HTML or examples for Flash, I don't go to these settings. These settings always build this global build file, and in this global you can even run this from command line using just Haxe without UI at all. So, and this global build file is where I just set what I want to build actually. So now I'm building JavaScript examples. That's the only one unmarked. So I'm going to mark that, and what is going to build is the test HXML build file, and this way you can have a hierarchical build file. So this will actually do just that. If you copy paste it this build file into this, that's the same thing. So, and you also need to take into account that the directory address of this build file is where Haxe is looking for everything. So when I set these directories here, that we have a flash context in this directory, is because it's relative to this build file. It's a context, common, and sources. There are sources for our flash context, not to this, because that would be like actual build file. but since we are building this, and this is just copy pasted into it internally, we are going to use a relative path from the build HXML. So again, these are the sources we will going to need. This is the Flash context, common files for all context, the Genome2D framework core sources, and our test sources. And we will need 2 libraries. We actually don't need the actuate, but I'm playing with a new UI components that use it, so that's why I'm using it here. But no class inside the swig file of the Genome2D actually uses actuate for now, but it will in later, because it's a great twinning library. It's the best so far I tried. And we are going to use msignal library, which are the signals that Genome2D uses instead of events. And last but not least is the Eagle, because since Eagle is Adobe's and they update it rarely, but they do lately with the Eagle 2, I decided not to rewrite Eagle in Haxe, because it's not cross-platform anyway, so we are going to use it for Flash target only. So I am including just the Eagle mini assembler compiled into the swig file and including it for all the Flash projects. So you also have it together with the context Flash. So here it is. It's just the Eagle mini assembler compiled into a swig file. So if you download the context Flash, you will have Eagle there, and that's why I point the library to the context Flash, lib, and Eagle. Next are debug flags. This tells Haxe that we are actually building a debug swift, and we are trying to connect the debugger there. So if you don't use this, you will not be able to debug into the console. Haxe will trace for example, trace messages into the actual Swift file, but this is to enable you to use the console for trace and for example error catching and stuff like that. These are Genome2D specific flags, and this is for Flash target is stage 3D only. What this tells Genome2D is that we are not going to use the bitmap fallback context, because if we don't specify this, Genome2D will compile using a eContext interface, and then we have this stage 3D context and bitmap context which implement the eContext interface. And if we are not able to initialize GPU, we can fall back to bitmap context, especially if there is no direct vmode set. But if we don't want this, why we wouldn't want this is because it's faster without it. It's faster because this implementation of eContext adds an overhead. It's obviously if you have a direct inlines, for example, it's faster than through implements and multiple contexts. That's a more complicated topic. I'm not going to talk about right now. But this tells Stage 3D that there is no such thing as eContext interface and multiple context classes. It will type def the eContext to actual G Stage 3D context. So there will be actual two classes inside Genome2D, and that is the eContext class and GStage 3D context class, but they are exactly the same because this is type def to this. So all context calls are directly to the Stage 3D context. It's not a call to the interface which is implemented by either bitmap or Stage 3D. I would use this all the time that I'm sure that I can initialize the Stage 3D, and I'm sure I'm not going to use the custom Genome2D bitmap fallback context, so I use this pretty much all the time. But it's there. Next are Haxe specific flags. This I'll mark there because I'm not going to use them. And this is no inline. It will tell Haxe that it should ignore all inline code, and compile it at this as at not inlined. This is great for debugging, because sometimes if you debug inlined code, it will throw an error in a place where the actual error isn't happening, because all the code is inlined there. So for debugging, if you are confused like what's happening, definitely try no inline. And no traces, it will disable tracing to Haxe console, but I don't need that now. It has no impact on performance. Next is the main class, which will compile, which is test, our project test. Oh, here we are not going to specify the path here, because they are specified here, and this is just a package. It's not in any package. It's the root package actually. So if it was, for example, like com genome, you would specify it there. Yeah, but this is inside the root package, so just like main test. And last is a flash specific flags for a Haxe compiler, and this is we will specify that we are using Swift version 12. I always use the latest one. And next is our output file and a predefined stage. So what will initialize if we run a standalone player. So it's 800 by 60 and running at 60 frames with black background. So when we compile it, it will compile to out directory. We don't have it here because IntelliJ ignores the out directory for cleaner structure. So let's try it out. And as you can see, it's here. This is my simple example where I showed how to implement rectangle mask with draggable high resolution image. It doesn't matter, it's just that we are just building these Haxe sources using GitHub stuff, and it works like a charm. So again, let's reiterate, I have all these GitHub repositories set up in individual directories, and then I have this build global HXML build file where I just switch what I want to build. And it's better because it's always the Haxe compiler is always run at this path, and it compiles from this directory path, so all my build files can tell that they have all the same. Because let's check this, for example, build file for the Swig. Again, since we are building this, the directory path for the context didn't change at all. So I hope it was helpful, and if you run into any problems building Haxe examples or anything using Genome2D, just let me know, and I will try to answer all the questions at our Google group. Cheers!